to another episode of Space Talks with Z. Thank you all very much for joining us for a very special session. We have Ken Peterman, formerly president of Viasat Government Systems, and Jason Kim, CEO of Millennium Space Systems, a Boeing company. This is going to be a really exciting event. I'm going to introduce the two gentlemen here briefly, but I want to recognize Millennium Space Systems, a sponsor of the America's Future Series, and also a sponsor particularly of the upcoming Innovation Days in the first week of October. Welcome, gentlemen, and thank you so much for joining us today for what's sure to be a very relevant and interesting conversation. How are we all this morning?
Thank you, Z.
Thank you, Z. It's a pleasure to be here. America's Future Series does a great job with this kind of thing, and Jason and I will try to pull our weight today.
No doubt, no doubt. Folks, we've got a couple of gentlemen here with tremendous experience in aerospace and defense. Ken came up through Rockwell Collins, was at ITT, and then was at Viasat for a number of years, really helping to bring about a new paradigm in satellite systems and platforms for government and defense. Jason, after being in the U.S. Air Force, thank you for your service, sir, worked at Northrop Grumman, then went to Millennium for a little while, left to go to Raytheon, and then came back as president and now CEO of Millennium Space Systems. Another, real veteran, not only of the Air Force, but also of aerospace and defense. And gentlemen, to start us off, I'd love for you both to talk about kind of how you got here. Your paths have been different, but very interesting. And I think are really informative to everybody about how one becomes part of the space economy. Jump in, whoever would like to go first.
Well, I'll jump in. I thank you. Thank you, Z. I'll tell you that as I've now crossed 4 decades in aerospace and defense, and I started with a double-E degree and came out of school in engineering, moved through a progression that's probably much like others. I was involved in engineering. I was involved then in engineering leadership. I moved into program management, led programs, ultimately moved into business development and led some various pursuits. So I saw kind of the whole thing. But I'll tell you that the thing that was important to me, and I think that's important to many of us, is we had to find our passion. My father was a college basketball coach and physics professor, and basketball was his love. And I grew up in Indiana. My grandfather was a high school basketball coach. Basketball's a big thing in Indiana. And my father loved it. To him, if you would ask him, he would tell you that he never worked a day in his life. And his advice to me when I was a junior or senior in high school was, find that thing that you love to do. Find that thing that you would do for free. And if you can get somebody to pay you to do that, you'll never work a day in your life. So find your passion and then be bold and do that. Okay. And fortunately, my passion has become the warfighter. My passion has become bringing technology-enabled capabilities to our sons and daughters in uniform. And I've been very fortunate that people have been willing to pay me to do that. and I think, and Jason, I think you're in a similar vote. You started with the uniform on, right? So I think that you're in a similar place.
Yeah, absolutely, Ken. I really appreciate everything you said just now. And I knew there was an impedance match between you and me, Ken, because I'm also an electrical engineering background as well. So I grew up in Texas, and my father, similar to what Ken's father did, inspired me. And growing up in Texas, he would always instill in me, hey, give back, son, give back to the nation. And the reason why is because our family was afforded so many opportunities. 2 older brothers that went to college and went to grad school, did a lot. And then, when it came down to me, I wasn't going to put my father through all that in his retirement. So I decided to go to the military academies and got into the Air Force Academy and got to jump out of planes and fly gliders and do a lot of things to include making great, long-lasting friends and relationships. And from that experience, going into the Air Force, I absolutely love the Air Force, and I bleed blue. It's something that is ingrained in my thought process, and going from the Air Force to Northrop Grumman to Millennium Space Systems to Raytheon and back here, that's something that is not lost on me. We continue to do this because we're giving back to the nation and helping our service members come back safely. And that's really what drives the philosophy and the passion at Millennium Space Systems.
I wanted to ask you, we have the privilege now of looking back on a career, and sometimes things jump out now that maybe didn't jump out at the time in terms of their relevance or their importance. And I wanted to share one thing, and that is that companies have different cultures. And I really started at Magnavox, a defense company, and we were acquired by Hughes Aircraft Company. And then Hughes Aircraft was acquired by Raytheon. And then I left there, and I was at, as Z said, I was at Rockwell Collins, which is now Collins Aerospace, and Cedar Rapids, Iowa. I think that one thing that's important, we all know sports teams have cultures. The Dallas Cowboys are different than the Las Vegas Raiders, et cetera. But we don't think of it so much in companies, but culture is really important. And I think that you have to find, it's important that young engineers, that young professionals find a culture that fits with them, that they can thrive in, that enables them to unleash their passion. Because what happens then is there's an energy in that, and it's a creative energy that unleashes innovation and makes the job fun, makes what you're doing professionally something that you enjoy, and then you'll be much more effective and create more innovative solutions and apply technology in more creative ways if you're in a culture that fits you. And I know culture was very important at Viasat. And I know Mark Dankberg since 1980 or 81, and it was his goal to create a culture that empowered and unleashed the creative energies of the best engineers in the world. And I think you've had a similar experience and been exposed to different cultures in different organizations. Sometimes within a company, different business units will have kind of different cultures. What's your experience? What's your perspective on that?
Yeah, Ken, I appreciate that. Culture is very, very important. We have a very special culture here at Millennium Space Systems, and so I'll say a few words about that. But I wanted to start off by saying, if you turn on the news, Ken, and you're part of the news as well. I read a lot of your postings and whatnot. You'll hear all about space in one way or another. New satellites going up with new technologies. There's plenty of new human spaceflight programs out there. I'm very excited about that. It's booming. And what's a little less well known, though, is the work that companies like Millennium Space Systems does. We're fast. That's part of our culture. We're fast. We're calculated risk takers. We're an agile small satellite company focused on national security space, as I said. We focus on the mission. That's part of our culture. It's bigger than ourselves, and our missions have direct impact to global security, like missile warning, missile defense, and Earth observation, and you'll see that in our portfolio. And we also, part of our culture is we focus on technology that supports our service members and brings them home safely, as I mentioned before. And we're always coming up with clever ways to revolutionize space. This is really, from a cultural standpoint, a prime company to kickstart your space career and transition your career. We have a lot of new, bright workforce that come to our company and also folks that have been in the industry for a while that just want to transition to something faster. And so you don't already have to be working in space, Ken, here at Millennium, because we use the latest commercial technology. I mentioned we're calculator risk takers. We're able to hire folks from other industries and companies, say like Apple, and apply their skills to what we do here. And that's the beauty of Millennium. You'll have the opportunity to grow and take on new challenges, and you can grow your career in many directions. There are things going on in the classified space world, and that's what we do a lot of here. And it may seem like sci-fi sometimes if we had told you all the things that we're doing, but it's not. It's technology we're working on today. And when you see it for yourself and you touch and feel and work on these programs, it all makes sense. And unlike other companies at Millennium, you'll see the results of your work. We've delivered things in 12 months, less than 24 months. So you'll get to actually touch every single facet of a spacecraft program, from conception to launch. And the greatest thing is when you see the satellites come together really quick in months, not years, but more importantly, when they launch, everybody has a sense of pride and accomplishment because every one of these members of our company had something important to contribute to that mission. And so it's a shared success. And that's what it's about here at Millennium. So Ken, are there similar type experiences from your side?
One of the things that's interesting about space and satellites that you talked about is there is this climax at the end. There is the launch, okay, and bringing it online. And I think in other technology sectors, like mobile networking or cybersecurity, there's not that event, okay, with that has the same. It's kind of it's an emotional climax for the team. And I think that you get that with space and satellites that maybe you don't get in other sectors. But the other thing I was going to talk about is, early in my career, when we were in aerospace and defense, and we were inventing satellite communications and inventing global positioning systems and inventing mobile networking, these things were all born in the defense industrial base, in the defense community, and their purpose was to enable our young men and women in uniform to be connected, to have that, to give them a sense of blue force, red force, situational awareness, to help them understand the world around them in a very stressful and difficult and rapidly changing environment. And these were challenges and technologies that the defense industrial base brought forward, and this was hard, okay. But the thing that comes to mind is that in many ways these different technology sectors were stovepipes. Okay, when you were inventing a satellite, things like mobile networking and cybersecurity didn't really cross your mind 30 years ago, okay. And the change we're seeing today is we're seeing these technology sectors come together and converge such that they're all part of the same ecosystem now, okay? And in some ways that makes the design challenge more complex, but from another perspective, it introduces diversity of thought and diversity of technology and diversity of process. It introduces this diversity into the equation. And, we talk about bringing the strength of diversity in terms of different perspectives, different background, different modes of behavior, different cultures. We talk about the strength of having a team that has significant diversity. And I think that now, when we talk about satellites and space systems, you can't talk about just the satellite without talking about the ground infrastructure, without talking about the terminal population, without talking about the network protocols, without talking about the cybersecurity attribute. And in fact, increasingly, we have to talk about the ability of a millennial space system to interoperate as part of a greater ecosystem with space systems that are built by other companies that operate in different orbital regimes that use different networking protocols and security protocols, because I think that so largely, I think while the problem is more complex and we have to be mindful of the entirety of the ecosystem now, it also brings diversity into the design team and a discussion, and that diversity creates energy and creates innovation and unleashes connectivity or unleashes creativity in ways that I did not see happening early in my career when we were just focused on our stovepipe. What are you've seen this? What are your thoughts?
Yeah, Ken, I appreciate your thoughts on secure systems. That kind of segues into the threat. And the threats are evolving so rapidly, and you've seen that through decades, Ken. And most recently, there's a lot going on in space right now. The number of launches have surged 50% in just 1 year. Maybe COVID has something to do with that. In the first half of this year, we've outpaced 2020 by 100%, and that's only going to continue to grow. And add to that, now space is a warfighting domain, like you said, Ken. And we know that because of what adversaries are doing in space. We saw the ASAT test in 2007 resulted in more than 3,000 pieces of debris in LEO. Are people still talking about that? There's robotics in space, robotic arms on satellites now. There's nesting dolls in LEO, and close to high-value assets. And if you were listening to everything going on just this week, the Secretary of the Air Force, Frank Kendall, made it clear we're effectively being challenged militarily. And countries like China are steadily growing their capabilities. At AFA conference this week, Kendall mentioned China 27 times. But he also said, one team, one fight. And that's where our secure systems and the diversity of all of our concepts and capabilities moving really, really fast to get those into the warfighter's hands. That's going to help our nation keep ahead of the curve. And that one team, one fight, that's absolutely true in how we approach national security space missions here. Our systems, like you said, Ken, play into the larger ecosystem. They're designed from the get-go to be interoperable, open architectures, agile, so that when you're on orbit, you can make changes in a good way. And that larger ecosystem, that's what we call multi-domain operations. We're migrating more towards that ecosystem that, Ken, you were talking about, where we all have to take our diverse capabilities, but interoperate and collaborate and work as one team for the fight. So all that is to help our service members at the end of the day. And so I agree with a lot of the points you're making, Ken.
Well, I'll tell you, I think your one team, one fight. Again, I want to speak to where we're going. Okay, and I'll start by where we've been. One team, one fight used to be, in my mind, that you had one defense contractor building the ground terminals or the ground hubs, those kinds of things. You had a different contract for the company building the space asset. You had a different contract for airborne user terminals or ground user terminals. And I could say that one team, one fight in the context of what I'll say is defense acquisition of 15 or 20 years ago used to mean that those companies had to come together and field an ecosystem that worked for the warfighter and that fit together and fielded on time and was aligned in its delivery schedule, was aligned in its operational performance, and those kinds of things. Today, one team, one fight can be looked at much more broadly. One team, one fight can be, yes, our warfighter sons and daughters are going to operate over military purpose-built networks. They're also, Jay Raymond, General Jay, the chief of the Space Force, has outlined the fighting SATCOM vision. And one of the things that is a fundamental aspect of the fighting SATCOM vision is that it brings military purpose-built together with these private sector systems. And we now, one team, one fight means that our warfighters need to be able to roam in and among private sector as well as military purpose-built. And I'd even go so far as to say that this type of a hybrid, diverse network brings resiliency, it brings security, and I'd even it's not too much of a stretch to think that just like your cell phone today has a software-based decision engine platform that parses traffic between Bluetooth and Wi-Fi and cellular. A warfighter's terminal in the not too distant future should be simultaneously connected to multiple diverse networks that utilize different frequency bands and different orbital regimes and different security protocols and different networking protocols, different ground infrastructure and all of that, and that the traffic is routed and parsed over these different networks such that it improves resiliency and makes it much harder on an adversary to disrupt the warfighter's ability to be connected. And in fact, this introduces the idea that, well, some of these private sector networks are perhaps not trusted, not fully trusted the way a military purpose built is. Yeah, of course, okay. But we're seeing techniques now where individual message traffic that gets parsed among different networks, perhaps we send the same packet over multiple networks, and it gives us a way to verify that the integrity of that packet at the receiving end, and increases diversity and resiliency in that perspective. So I think that as we think about one team, one fight, we now can stretch beyond the way we used to think of it before, and the team is bigger. The team is bigger. The team is more diverse. And there's strength in that. There's power in that.
Yeah, I totally agree, Ken. Just to pull on that thread even more, I just wanted to add that I like what you said towards the end, where the team is bigger, and I also agree with that. That now that it's the traditional military contractors working with the private sector and the commercial companies, that is a bigger team, and there's a lot of dual-use commercial technologies that are bouncing back and forth between those different entities. And I'll give you an example. If a missile is launched at the U.S., we need to quickly detect it and then track it so we can eliminate it, right? There's been traditional ways to do that in the past. For us, we're working on systems like the Space Force Track Custody prototype. It's a missile tracking system in MEO. This program is disrupting the traditional missile warning and defense industry. And it's because we're taking the bigger team of commercial and private industry and military industry working together to bring those technologies to bear. We have another example called Tetra, that we deliver for the Space Force in 13 months. It's going to launch later this year, and that's going to bring in new commercial technologies, onboard processing, to enable new techniques and tactics and procedures that will help our Guardians better understand space operations and what they're able to do now with that bigger team. And another really great example is our drag racer program. We demonstrated the ability to rapidly deorbit a satellite in LEO using a tether tape. And in less than 9 months, we built 2 identical spacecraft, and we used the scientific method of one had a tether on it and one didn't. And the satellite with the tether deorbited in just 8 months. The other one is still on orbit. And in a time where we're seeing thousands of spacecraft being put in low Earth orbit to connect the world, like you said, Ken, wouldn't it be nice to also have the sustainable LEO orbit by having deorbit technology built in? And this is technology that is low size and weight and power. So we're in a time where we anticipate thousands of satellites will launch over the next decade. The challenge, as you know, quickly becomes congestion, especially in LEO. Technologies like drag racer can help keep space less congested and sustainable. And our unique approach could reduce the number of satellites in LEO or even beyond, deliberately deorbiting them once they've reached the end of their operational life. So for us, what all of these systems have in common is they're very rapid in their development and delivery timelines. We're fast, and that can't change because we need these capabilities we're providing to help protect and defend the U.S. But it is one bigger team now that we can leverage the work that we're doing for the U.S. government, but also bringing in the technologies from the commercial sector and doing it in a very secure way, like you said, Ken. That's something that we agree upon and also practice in all of our systems.
One thing that's been really interesting between what you gentlemen are saying, and that's maybe a little bit of a subtle point that not all of our viewers would understand, is that, you know, there are two paradigms that you guys have operated in. Ken, you've operated primarily in large systems with satellites that are going to be up there for a decade, maybe more. Whereas Jason, you're talking about planning for down mass, right? So, you know, particularly in terms of the signal coming from the investment sector and the commercial sector, how do you see the interface between how long satellites are built to last and operational mission lifetimes interplaying with the evolving mission and the evolving situation and security that you gentlemen have described? I know it's a bit of a multi-layered question, but it seems that there's an interesting mesh that has to happen. And both of you are coming at it from a little bit of two different perspectives, right? I think the GPS satellites are the size of a school bus, right? If I remember correctly, they're huge. Whereas, you know, Jason, the other day when we chatted, you know, your sats are, you know, the size of a bowling ball, some of them, right? So it's very interesting. How do you see that ecosystem of scale, risk tolerance, length of operability, meshing with the security environment and the warfighter needs moving forward? I don't know which one you want to jump on that first, Ken. Or,
well, I'll jump in. I'll tell you that different orbits have different characteristics, and so it enables you have to approach them differently in some aspects. But in reality, the technology trajectory is what's driving this, and the threat trajectory is what's driving this. So you have the speed, the accelerated pace of both the technology trajectory, the accelerated pace and steepening trajectory of threat vectors are what drives it. So just because a geosynchronous satellite might have a life of 15 or 17 years, it doesn't mean that satellite's going to go up there and stay the same, and that you're going to be able to be commercially successful or militarily successful with 16 or 17-year-old technology downstream. Okay, I mean, if Verizon or AT&T said they're going to put a cell tower up next to your house, and by the way, they're not going to touch it for 17 years, you would say, hey, that's not going to work for me. Okay, so my point is, in LEO, the satellites have a shorter lifespan, 3-5 years. And so you get the opportunity to roll technology. You get the opportunity to evolve the technology. The challenge in LEO, I think, is that you have this constellation where the satellites are spaced at certain intervals in order to assure coverage and continuity and those kinds of things. And you never know which one's going to fail. So the challenge in LEO is getting the replacement satellite into position at an affordable launch cost and on an affordable timeline. And in some cases, the challenge is maintaining consistency of technology baseline among satellite constellation of varying launch age and that kind of thing. In GEO, the challenge is how do I make the software? How do I make the satellite upgradable when it's on orbit, so I can keep pace with technology, so that I can be competitive with satellites that deploy 5 years later or 7 years later or something like that, because I need to get the full value out of my resource, and I need to be both commercially and successful as well as militarily successful. So I think they have a common problem that has to be approached different ways. I'm very interested in Jason's perspective on this.
Yeah, Ken, thanks for that. You know, I really think that there's a lot of value to tech refresh. tech refreshability. And what I mean by that is both the national security space missions and the commercial markets need tech refresh. Every 3 to 5 years seems to be a sweet spot right now. And like Ken said, for the national security space market, the threats are driving that type of timeline. And so because threats are evolving and advancing, you want to also stay ahead of the curve by also evolving and advancing. And 3 to 5 years is a good sweet spot for that. But even in the commercial market with satellite communications, the technology using things like Moore's Law, the cycle times are improving. You like to think it's every 6 months, right? And in some cases it is, some cases it's not, but it's moving fast. And so even with the commercial markets, you could get a lot of return on investment by tech refreshing and bringing in the latest technologies that give you the better bandwidth, the better capabilities as technologies evolve terrestrially. And you want to take those type of models and technologies to on orbit. And that's where, Millennium Space Systems, we're about also tech refreshing and constantly enhancing our systems and evolving our systems. And that takes adaptability, it takes flexibility. And so we're always continuing to look for ways that small satellites can disrupt the industry. And that includes everything from how we work and build the systems to what orbits we can operate in. Like Ken said, it's not just about LEO, but there's very low Earth orbit, there's LEO, there's MEO, there's GEO, there's cislunar. And I'll give you an example. We're working toward what I call a digitally defined small satellite company. The future vision is working towards a true digital thread throughout a satellite's lifetime. I mentioned before that at Millennium you can see from inception to design all the way to AIT to launch integration to launch operations and seeing the sustainment. You want to have a digital thread throughout that life cycle. And that's for prototypes and constellations. So from digital twins to building in digitally defined assembly lines, that's what we're doing. And everyone's talking about LEO, but we'd be remiss if we didn't also look at the effective advantages of other orbits like MEO, cislunar, and very low Earth orbit. And another example of having evolving technologies in 3 to 5 year lifetimes and being able to adapt and be flexible to different missions and technologies is we're also working on 3D printed buses right now. And we just 3D printed a primary structure with aluminum and secondary structure with titanium. So it's a 3D printed aluminum and titanium bus. And I think that future is tremendous. It can drastically improve the build schedules and costs and enhance the mass as well. But you could also, in the pipeline, the assembly line, rapidly adapt the structure to accommodate new technologies and tech refresh, even in the digitally defined assembly line. And so that's a future that really excites me at Millennium Space Systems, because we are investing in that and also executing on programs with that technology. And it's going to allow us to continue to tech refresh on those 3 to 5 year life timelines.
Mm-hmm. Z, I know you're recording. I need to take a 2-minute break. I'm at 6% on my battery, and I got to get a plug on this thing or I'm going to lose you. So I'm going to get up and get my plug on.
Okay, we're going to pause.
So for this first one, it looks like.
And so, gents, with the advanced manufacturing concepts that are being brought forward now, how do you see that affecting the workforce of the future and engineering needs, as even your engineers need to design for a new way of manufacturing? And what other workforce needs do you see evolving for yourselves?
I'll tell you, Jason probably has a very thoughtful perspective on this. I think we need to move. Look, machine learning and AI digital threads, things are going to enable the design process going forward that automate a lot of things in ways that we couldn't do 5 or 10 or 15 years ago. So in some ways, I think our workforce needs to be more aware and knowledgeable of the entire ecosystem. They need to be participating in the imagineering of future capabilities, imagineering the escalating threat vectors, imagineering the evolving use cases. When we had a flip phone, life was pretty good. Okay, we went to the BlackBerry, and I thought I had found perfection because I could do email and I could do voice with a single device that fit in my pocket of my sport coat. Okay, and I have to admit, as a user, I did not call for a smartphone. I did not, that from the user community, I didn't realize that was in the technology art of the possible, and therefore never put the call out to industry that said, I want to do restaurant reservations, online banking. I want to check into my hotel from the taxi on the way to the hotel and download my room key and go straight to my room. I did not envision that was the use case that was possible. And so in some ways, I think it's really important that our talent and our workforce demonstrate the ability to think beyond our current customers' paradigm and our current customers' limitations. And that's especially true with the warfighter, because I think so many times when we read the request for proposals or something, what we see is an incremental improvement to the status quo, something that's smaller and lighter, and the batteries last longer, and it operates at a higher data rate. But what we're not seeing a call for is necessarily is a step function change in capability, a step function change in empowerment. And so I think in large part, we need engineers in our workforce that can envision and put technology to work for our warfighter customers in ways that delight them, surprise them, in some cases shock them, that was in the art of the possible. And I think as leaders, it imposes on us a responsibility to not just unleash and empower workforce from a talent perspective, but also be on the lookout for talent that might be hidden or might need to be identified and unleashed. Early in my career, this was back in the day when we had company picnics. Lordy, everybody, that's going to shock people, I suppose. But I was at a company picnic, and they had they were doing little games. Okay. And one of the games, we were in like 5-person teams, and I had my little engineering team, and we were doing a game. And here's the game. Okay, they gave us like a grocery bag, and it had office supplies in it. It had a poster board that's like 2 feet by 3 feet, and then it had paper clips and masking tape and office supplies. And they said, here's the rules of the game. Okay, every team gets 5 minutes, and your job. And by the way, in the bag was also a thumbtack, a rubber band, and a little propeller. And it said, here's the game. You get 5 minutes, construct whatever kind of flying device you want. And at the end of 5 minutes, we're going to blow the whistle. And whoever's flying device travels the farthest wins the game. Okay, so guess what? There's like 35 teams, and you can imagine that everybody's doing the same thing. They take the poster board, they fold it like a paper airplane, they stick the masking tape in the paper clips, and they figure out a way to stick it to the fuselage. But fundamentally, we're going to throw this airplane. And some people with absolutely no aerodynamic experience or expertise at all are actually trying to put the propeller on the front of this thing and stretch the rubber band and use the thumbtack in the back, thinking that this little bitty propeller is going to pull the weight of this poster board very far. So you have all these teams doing the same thing. And I'm a young engineering section leader with my little team. And on my team was a fella that was the center fielder of our company softball team. He's like 6'4" and all this other stuff. And finally, I just thought, this is ridiculous. What a ridiculous game. And everybody's doing the same thing. So I about 2 minutes in, I said, listen, huddle up. Okay, we're gonna do something different. I said, look, if we just wad this thing up as small as we possibly can and wrap the masking tape around it, I said, it's going to look like what? And Jimmy and the center field, he says, a softball. And I said, exactly. I said, how far can you throw a softball if we just make this thing like a rock? He said, I can throw it 100 yards. I said, okay, let's do that. Okay. And so we did that. And so while the team was doing that, I walked off to these folks refereeing this thing. And I said, listen, we'd like to go last. Okay. If nobody else has reserved that spot, let everybody else go ahead of us because we're doing something a little bit innovative. And they said, sure, no problem. So everybody, the 5 minutes passed and you know what happened next. These little airplanes, they all did this and it was kind of pathetic and got to be our turn. And Jimmy stood up with this thing in his hand. And of course, everybody cried foul and they said, no, that doesn't, and he heaved the thing like, I don't know, 150 yards. And I declared that we won the game. And the referees huddled for a minute and said, well, there's only 2 rules. Use everything in the bag and you only get 5 minutes. I said, we didn't violate any of those 2 rules. So we won the game, okay? Now, the reason I tell this story is because shortly thereafter, the CEO of the company, like 5 minutes later, walked over to our little group. And, I'd never had a conversation with him before, okay? And I don't think he knew the names of any of us. And he walked up and said, well, that was a very innovative thing that you did. He said, who was responsible for that idea? Well, this was the part where I thought I was going to get chewed out, okay? And everybody on my team said, it was him, okay? It was his idea. And I'll tell you what happened next is he said, you think a little differently than other people. And he said, that intrigues me. He said, I'm going to have my secretary call you. I'd like you to come up to my office next week and spend a little time with me because I'd like to get to know you a little better. And I can tell you, looking back on it, my life changed. My professional life changed because the first thing you know, he started putting me in charge of projects that were in trouble. And he put me on projects that needed a better idea, okay? And I started to get exposure and opportunity that I wouldn't have got had we not done something that was different than what everybody else was doing. And so I tell you, that story sticks with me, and I don't mean to belabor it, but I think as leaders, we need to look for opportunities to identify people that think a little differently. And we need to look for ways to harness, exploit, leverage those talents. And that's part of the diversity question we talked about a little earlier. But I think, and I'll tell you what, as in a virtual environment, where we have a distributed workforce. And sometimes when we have classified programs and things like that, there's challenges. There's challenges in especially as organizations are large. Okay, so I think as a leader, I've challenged myself to try to be in touch with talent, the talent pipeline, to be able to identify people that think a little differently and to exploit that talent. Jason, I know you must have a story. I'd love to hear. I'd love to hear your perspective on that.
No, I love your story, Ken. You'd fit right in at Millennium Space Systems, and at a broader picture, that's, if you look at the Boeing acquisition in 2018 of Millennium Space Systems, they looked at us the same way. They said, hey, you at Millennium Space Systems, y'all think differently. And to this day, Boeing wants us to keep our culture and our brand identity because we think differently. And those alternative thinkings is really helping provide that diversity of thought that Ken mentioned before. It's coming up with different alternative solutions that could be game-changing and disruptive to the industry and add a lot of value to our customers and their missions and pass the cost and schedule savings to them as well. And so I got to, tie the 2 stories, Ken, your story and what Boeing and Millennium are doing. And Boeing, in a lot of ways, has helped us grow up. We were a small company, privately owned company. There was no way we would have had the broad resources that the greater Boeing company has to bear. And so now that we're part of Boeing, we've grown a lot, and that growth is supported by new enhanced processes and technology roadmaps. And Boeing's been instrumental in providing those resources for us to expand, and they continue to invest in us for the future. And we've been able to lean on them for their extensive production experience. I mentioned having a digitally defined assembly line. They're helping us with digital engineering capabilities and model-based systems engineering. Those are things that are very beneficial and modern techniques of doing advanced development and high volume production that the next generation workforce is taking advantage of. They're really leveraging it and doubling down on it, and we are too. And we started off this conversation about the additive manufacturing and the new production methods. Because we're going more towards constellations, not just prototypes, but also prototypes and constellations, we're looking at high volume production systems. And part of that, it's not just about the production systems. There's a design for manufacturability and test aspect of this too. And so those are new techniques that we're bringing towards small satellite development, and our workforce is taking advantage of those new techniques and learning how to design and develop systems that will be more efficient in the back end of producing them in high quantities. And also, when you launch them on orbit, we learn a lot, as Ken can elaborate on. We learn a lot from mission operations as well. And so having this feedback loop of digital engineering between the designers and the high volume producers and the mission operations people is really going to connect this ecosystem so that we can drive towards the future of a digitally defined small satellite constellation enterprise. And so that's where I see the next generation workforce really helping us get to that vision.
I think in some ways the workforce, they need to really be in touch with the customer's use case, the customer's problem to be solved. In some cases, our engineers, you wore the uniform, and thank you for your service. Many of our engineers have not, okay? And so in many ways, I told a story earlier about, I wasn't informed enough to ask for a smartphone. I was happy with my BlackBerry. I would have liked it a little thinner. I would have liked the battery to last a little longer, but fundamentally, I didn't think that the smartphone was in the technology art of the possible. It was Steve Jobs that came forward and said, listen, I know Ken Peterman's use case better than he does. He's never going to ask for this, but I'm going to bring it, okay? And when I bring it, Ken Peterman's going to love it, okay? And I think in some cases, we've got to get our engineers to crawl into the airplane or crawl into the foxhole and understand what it's like to be that son or daughter that's in uniform, so that they can, because if they spend a day in the foxhole, they would say, boy, here's what I'm going to bring you, because it's going to change everything. Okay. And so there's a customer intimacy, an intimacy with the customer's use case, emerging use case, where our technologies can empower customers much more effectively, the deeper understanding they have of what it's like, what life is like for the customer. So I think in some ways, I think we don't want to lose sight of that. That's where the innovation and the technology, applying technology to the customer use case, that's where that's going to come from.
So jumping off of that, Ken, looking to the future, and as we're reaching kind of the bottom of the hour here, thinking about what next, what's needed next, what can be provided next. I think one of the things that your comment highlights at a huge level, something Jason, I'm sure, understands viscerally, because he's a demonstration of that, is the value of veterans in this workforce, right? That understanding is no more intimate for anybody but them, of course. But also just kind of looking forward, advanced manufacturing is actually now 15 or 20 years old as a technology, right? And so now it's in that part of the hype curve where it's performing and delivering, right? I'm curious as to, you gentlemen see things 10 years down. I'm curious as to what you think is going to be next, and what the workforce needs to be training on, what people need to be thinking about, what innovators should be jumping on for the next 15 years.
Jason, you want to go first, or how?
Sure.
You want me?
Sure. I can start off, and then we can bounce off each other. So I think one of the next technologies that has a lot of game-changing potential is 3D printing and additive manufacturing. As I mentioned before, we 3D printed an aluminum titanium bus, and we look forward to launching that very soon. That technology has a lot of schedule savings. You can go from potentially 6 months down to 1 month in delivery of an entire primary structure. There's a lot of cost savings as well associated with that. And there's mass savings, like I mentioned before. And you can put just the right amount of structural capability where you need it. And there's also the opportunity to be flexible, because you could have interchangeability where you could switch out a payload or switch out a subsystem. And you could readily do that with 3D printing, because you could just 3D print a new digitally defined design from that point in the life cycle of the program. So the 3D printed spacecraft small spacecraft is something that I think is game changing. You're already seeing it in the launch vehicle side with companies that are, whether they're 3D printing components or large portions of their launch vehicles, or even in some cases the entire launch vehicle. That's a much bigger scale of the benefits of 3D printing, but even for small satellites at the smaller scales, we're seeing a lot of benefits to that. And I think that's an exciting technology that gets our mechanical engineers and our manufacturing engineers very excited, and our technicians. I mean, where else do they get to work on 3D printed spacecraft? It's a very special kind of technology that has a lot of benefits and a lot of new ways of developing that type of system. So like Ken said before, it really sparks our workforce's curiosity. It allows them to try new things and not be afraid of failure, but learn from it so that we can ensure quality and final delivery. And so there's a lot of benefits to 3D printing of our small satellites that is going to be a next generation game-changing technology.
Okay. I think that's a great point. I think, thinking back when I came out of university with my technical degree, I'll tell you, I wanted to go into the defense industrial base because all the cool stuff was happening there. I mean, we were inventing GPS, and we were inventing satellite communications and mobile networking and that kind of thing. And I wanted to be part of that because it was the hard problem that was being solved. And I think it's different today. I think that in many ways, the private sector has embraced these technologies. And now we see the private sector accelerating technology trajectories in ways that frankly, the defense acquisition community can't keep pace with. So we see private sector companies moving really fast. And I think in many ways, the talent pipeline coming out of university now migrates to these private sector companies. Space is a big part of that, but they want to work in an environment that moves fast. They want to work in an environment that enables opportunity for themselves, but also challenges for themselves. And they want to work on an accelerated timeline with technologies that are cutting edge. And so, what I think is going to happen, what that means is I think that increasingly, I think you're going to see DoD operate over these hybrid systems that blend private sector network capabilities with military purpose built. And I think that they're not going to, and it's not just going to be confined to space and satellite networks. I think we're going to see warfighters start to roam seamlessly between private sector as well as military purpose built. But I think they're going to be moving seamlessly between terrestrial and space systems. And I think they're going to look at the connectivity around the planet as one holistic fabric that they roam in and among terrestrial as well as space. And I think that as the private sector commercial use case becomes more challenging, I believe it even maybe surpasses the difficulty and the complexity of the military use case. Think of driverless connected cars moving down the I-5 between Jason's facility in El Segundo and me here in Southern California in the Carlsbad Encinitas area. Cars are moving down the 5 at 85 or 90 miles an hour. They're 3 feet from the car to their right or their left. They're maybe 15 feet from the car ahead or behind. And they're taking their hands off the wheel because the car's got this covered, okay? So the car, the challenge of the connected car in terms of latency and connectivity. And by the way, the difference between that car being a transportation device and a 2-ton kinetic weapon is one cyber attack. Okay, so the fact is, the challenge in the private sector of connected cars, the challenge in the private sector of small package delivery by drone, where we might have millions of small drones out there the size of a card table. I don't know if anybody knows what a card table is anymore, but you know, that are delivering Chick-fil-A, and they're delivering pharmaceuticals, and they're delivering pizza and dropping it on your doorstep. The connectivity challenge in the private sector is enormous, okay? And I believe that and billions are being spent extremely rapidly, and there's an economy of scale that comes from that, because you know because the world builds millions of cars every year, and the world's going to build millions of small drones every year, and I think that the use case in the private sector for assured, secure, low latency, high bandwidth connectivity is the demand is absolutely going to be there. And I think that our warfighters have an opportunity to leverage that technology dividend in the future in a way that they have never been able to do before, because the military problem was always the hardest one. And I think in many ways, this connected car, connected drone, the scale of that, the complexity of that, I think that in many ways that is reaching or overcoming and surpassing the challenges in the military. So it's going to attract our best talent. It's going to create opportunities for the military user to hide in plain sight among this complex ecosystem of connectivity options. And I think it's going to change the way we think. It's going to change the way we fight. It's going to change how we define one team, one fight, in the way we collectively try to empower our sons and daughters in uniform to be safer and more mission effective than ever before.
Mike and Chris.
Well,
Do you
Jason,
anticipate
Ken, you know, thank you again for joining us. I just want to ask if you guys have any specific recommendations or that you might give our audience and people who are thinking of this.
Well, if you're
yeah, go ahead.
Well, I was just going to say, look, if you're in defense or you're a uniformed warfighter, I think it becomes increasingly important that you be knowledgeable and aware of how these private sector SATCOM or terrestrial networks perform in your warfighter use case, running your warfighter application software in benign and contested environments. I think it's important that you have insight into that. And if you're in the workforce or coming out with a technical degree, this is an extraordinarily exciting market segment. The technology is moving really fast. It will challenge you to keep up, and it will unleash enormous creative energy inside yourself to be able to apply these technologies to meaningful applications, such as the defense of this country, such as the safety of our sons and daughters in uniform, and the improved mission effectiveness and the empowerment that they can get. So my advice would be, look at this segment hard, be passionate, unleash your own passion. Our sons and daughters that choose to serve this nation, to adorn themselves in the cloth of this nation and serve, okay, they deserve nothing less than our very best technology, and it's been a very rewarding for, I know, Jason as well as myself, to be a part of that. Okay, and so look deeply within yourself and choose wisely.
Jason, last word to you, sir.
Those are great wise words from Ken Peterman. Thank you for that. Space is truly a groundbreaking industry. I hope you got some of that from our conversation today. There's so much exciting work happening right now. It's ripe with opportunity. What I'll say is consider Millennium Space Systems and National Security Space. And if you don't think that national security space is it's not for you, think about this. Not only are we helping our country and our service members and our allies every day, there's things like ATM machines, GPS receivers, paying with credit cards, all sorts of everyday facets of our lives that are enabled by space. All this is because of the work this industry, the space industry does. There's future benefits to everyday life that we're seeing just spring up, just like what Ken said before, when there's an age of inventing all these new things. That's happening again right now, and will continue to come out. All these new inventions will come out of the work we do for national security space, like Ken mentioned too. Plus, we're in a fun community. I think Ken would agree. This is a fun community. It's a small community. We all know each other. We work with each other. We depend on each other. And Millennium, I know we have a lot of members that are curious. We think differently. We challenge the status quo. And when we see that launch, like I said before, when you see that launch, we're all excited. We all participated and contributed to make that happen. But there's no better feeling in the space industry than seeing your spacecraft turn on and perform that mission for your customers. And so that's the thing that I think my biggest advice is get an opportunity to do that, because it's a life-changing opportunity. Thanks, Ken. Thanks, Z.
Jason, thank you. Z, thanks so much. It's been I've enjoyed talking to you and Jason very much this morning.
Well, thank you guys. Folks, we've got Jason Kim, President of Millennium Space Systems, Ken Peterman, formerly President of Government Systems at Viasat, who have joined us today. Thank you both for joining another amazing Space Talks with Z, and we look forward to your comments at the Space Innovation Days. Thank you, gents.